Hello and welcome to Extension 2 Maths, where the real and imaginary collide. Before we formally introduce complex numbers, it makes sense to go back in history, back in time, to where they were first used, and that's in Italy in the 1500s. At the time, meaningful employment as a mathematician meant you were either employed by a university or someone with money who wanted you to do some sort of task for them. It might be the Navy, it might be a noble that has some engineering problems, something like that. Anyway, you needed to be known to have a chance of being hired, basically. You can't hire someone if you don't know who they are. So that led to secrecy. If you knew something that other mathematicians didn't, you could solve problems other mathematicians couldn't. And that's a surefire way to get to make a name for yourself, which is quite different to the modern world, where mathematicians work together, publish results, and it gets reviewed in peer-reviewed journals. At the time, mathematicians would often challenge each other to a duel, a mathematical duel of intellect, not with guns, obviously. They would solve a series of problems set by each other, and whoever solved the most problems was the winner. The winner gets street cred, and with street cred, you make a name for yourself, and that's how you're going to get that meaningful employment. Our story has three main characters. The first character is Niccolò Fontana Tartaglia. Now, he had one of those secret weapons. There were mathematicians that knew how to solve certain cubic equations, but they didn't know how to solve all of them. No one knew how to solve all of them until Tartaglia. He clearly had a general solution for any cubic equation, and he was making a name for himself. This is where our second character comes in, Girolamo Cardano. He was already an established mathematician, and he was very interested in this formula. In particular, how did this formula relate to the quadratic formula? How did it relate to the special solutions that people already had? And could it be used to find a solution to the quartic problem as well? Somehow he convinced Tartaglia to provide him with that formula. In his research, he discovered the third character, Scipione del Ferro. He found out that del Ferro had come up with a solution to the cubic as well, independently of Tartaglia and before Tartaglia. That last point's important. I haven't mentioned it until this point, but the only reason that Tartaglia provided Cardano with the solution was that, with the proviso, I should say, that he also kept that solution secret. He didn't publish it. He could use it in his research to do whatever he wanted, but he just couldn't publish the actual formula. But once Cardano discovered that del Ferro had come up with a solution before Tartaglia, he no longer felt that he had to honour that agreement. This led to a lifelong feud between Tartaglia and Cardano. Tartaglia felt betrayed, and he felt that Cardano had stolen his work. Cardano is most famous for a monumental book that he published called Ars Magna. This book is all about the arithmetic of negative numbers. He goes through and meticulously builds up the theory of how to work with negative numbers, as well as introducing work on the quadratic formula, the cubic formula, and that quartic formula. He never solved the solution. It was one of his students, but he published it in this book. Now, it may surprise you to understand that mathematicians would want a huge book on how to work with negative numbers. But in fact, at the time, they were really struggling to understand how to work with negative numbers. Surprising now, given that we teach it in Year 7, but back then, in the 1500s, it was a new thing. And it was Cardano's work, his book, that kind of took them down the path of understanding how to work with negative numbers, and that's why we now can understand it much earlier in our careers. But it's on page 66 where our interest should lie. And it's a seemingly innocent example problem in the quadratic equation section. It's a problem where Cardano asks that the number 10 is split into two equal pieces that multiply to give 40. And if you think about that quickly, you can see you can't do that. 1 times 9 is 9, 2 times 8 is 16. You can't get to 40. But what Cardano does, he proceeds anyway. He says, well, I'm a mathematician, let's have a look, let's have a play, let's see what happens. So he turns it into a geometry problem. He turns that 10 into a line segment, splits it into two pieces, and forms two squares, 5 by 5, 25. He also introduces a rectangle, and because we're working with areas now, with squared objects, he can turn it into a problem involving a quadratic, and he can use the quadratic formula to solve the problem. In his solution, he innocently allows the square root of a negative number. I mean, they were stressed enough about negative numbers themselves at this point, so why not throw it into a square root as well? And this is the first recorded use of complex numbers. Now, Cardano clearly had no idea how important this innocent little result was. Excuse me, I'm going to read this quote off the screen that he wrote just after going through this example and showing the solution in terms of these negative square roots. He wrote, "So progresses the arithmetic subtlety, the end of which, as is said, is refined as it is useless." If only he knew how wrong he was. Thanks for watching.